Hello everyone, my name is Lina Pinson and this time I will talk about the progress of the work in development called obtaining nanocomposites formed by Kaolinite Tetraethylammonium reinforcement material in the polymeric matrix of polyvinyl called PVA. Introducing the substrate Kaolinite, unlike other clays, presence is the interlaminar layer electrical neutral. This limits the interlayer expansions and becomes a challenge for the intercalation of organic molecules. The interior students Kaolinite intercalation complex arise from their accessibility and abundance. It show be note that in Colombia, that in the region of Boyacá, there are the deposits of kaolinitic clays. Therefore, in the study, a structural modification were made of a kaolinite extracted from the M4 region and a dry Kr kaolinite with the objective of obtaining nanocomposites to reinforce the PVA polymeric matrix from the elaboration of the cast films and evaluation of their mechanical properties. In the methodology, initially, a purification process was carried of sodium hexametaphosphate and homogenization with sodium in both places. Then the intercalation process will carry out. This first one using 10SO with the induction a radius of temperature 100 of degrees Celsius. For 8 days, then the temperature was removed and starting was continuing for 5 more days. The product was washed with dioxane and isopropanol. Then it was intercalated with methanol to obtain of methoxykaolinate using the initial ratio. It started for 9 days, changing the methanol once day. Finally, intercalation with the air was performed following this radio for 24 hours under rotation. Cal DEMSO and Cal pH materials were chosen by reinforcement in 10% PV films with percentage of 0.636, 8, and 10% with the respect to the mass of the PVA. The solution were prepared in 5% ethanol and 70 and 80 degrees Celsius for 3 hours. They were dropped at 40 with 40 degrees Celsius with 40% humidity for 2 days and at 75% humidity. In the results and discussion, table 1 shows a results of the XRF analysis of the oxy composition of Kr and N4. It's highlighted that the percentage of silicon and aluminum oxide vary notable between the claims, which indicates that the N4 clays present a high quartz content in front and semi-quantitative analysis was obtained that the mineralogical compositions present 48% of quartz and 52% of kaolinite. In addition, it observed that the homogenization process with sodium, the cation exchange occurs between magnesium and calcium and sodium and generates the decrease in the percentage of the oxides. Figure A of the XRD results shows the results mineralogical composition of the N4 clay versus Kr, where the quartz phase for N4 presented greater intensity than Kr. However, N4 presents the characterized phase in 00T and 001 of Kaolinite. In figure B, we observed the diffractograms of the intercalation complexes 10. Initially, the original materials are observed with after forming the complex with dense O increase their initial basal as the basal spacing with the displacing of the kaolinite phase. Then in green color, it's observed that the methoxykaolinite complex was only obtained for the Kr clay and the kaolinite phase M4 return to the initial positions. Finally, the complex was only for the cave clay and the kaolinite phase return of the position. Finally, the complex with TEH is only forming with the Kr and it's surveyed with the increase in basal spacing up to 1.522. The XRT results are related to the AR spectral where the organic functional groups on the intercalation compounds are highlighted. Initially, in the sun, we have the signals of the hydroxyl groups on the surface on the kaolinites. Then, for M4 and Kr, two new things appear for the complex with DMSO that correspond to the hydrogen bonds between DMSO and the OH groups on the octahedral surface of the clay. For the complex with methanol, the disappearance of DMSO signals and the presence of water molecules derived from methanol that the formation of methoxykaolinite are observed. Finally, the complex with TH, it reflects with the band at 1,400 and FTFTA corresponding to the ammonium group. In the figure 6, shows the SEN micrograph and EDS analysis of the Kr and M4 kaolinites. Figure A and B and C show the pseudo-hexagonal and highly ordered morphology of the kaolinites due to the high content of kaolinite phase of Kr on the other phase of Kr. On the other hand, figure E shows the abundance of quartz grains and the other impurities such as iron with agregates with the EDS as RF, XRF analysis of M4. Finally, mechanical properties. In the evaluation of these properties, progress was made with the nanocomposites with dense O and remarkable results we obtained on the presence of 6, 8, and 10% in the shown modulo if what's obtained than the fields with M4 present higher steam more than KR with a percent on 6%. And also the massing strength for M4 increased up to 3 times more than Kr with a percentage of 8%. On the other hand, the percentage on elongation for Kr is up to of times then for M4 with a percentage 10%. In conclusions, the successful intercalation of methoxykaolinite and pH complex is not possible for kaolinite and due to the effects of dispersed quartz in the clay, with the restrict necessary availability of kaolinite for this process. In addition, it is observed that in the analysis of mechanical properties, results stand of the higher percentage of nanocomposites in the PVA matrix, 6, 8, and 10%. It's evidence that the films derived from exhibiting higher stiffness and resistance to rupture, while the films with KR show higher plasticity. Thank you so much.